So this first section here says, fill in the following blanks with formulas or explanations. Google any you don't remember. So try to remember it from your own memory first. Perimeter of a square, area of a square, volume of a cube. If you can't remember it, then use Google. And then you'll go to the second section that says, use the information you found to write an expression for the following things. So this means like, kind of like a formula. So see what you come up with. And if you're watching the video asynchronously, just pause and do these two sections on your own. Cool. Here's what I was looking for that I hope you came up with. For the perimeter of a square, if you were just, giving that as an explanation, I was looking for something like where you said you just add up all sides. Right? That's what the perimeter of a square means. The area of the square is when you multiply the length times width. And squares are flat. So for A, we're talking about a flat square. For B, we're talking about a flat square. Oh, I'm sorry, you guys, the screen's frozen. I apologize. Too many things to remember. Okay. But when you talk about volume of a cube for part C, a cube is like a square, but in 3 dimensions. So, when you draw this, right, that's a square in 3 dimensions is a cube. And when you talk about the volume of a cube, it's the area of the square on bottom times the height. So you have the square on bottom times the height of the cube, and then that gives you the volume, right? So if you filled up a cube with water, that signifies that indicates the volume of the shape. And so that's length times width, but then also times the height of the figure. And so then in the next section, when I was asking you to use that information to write an expression or formula for these shapes that have sides that measure x. So it's an unknown, okay? So for perimeter of a square, it would be, so if each side is x, and you were going to add them all up, it would be x plus x plus x. It would be 4x units. Right? That's how you would come up with your own formula. For the area of a square with the side of x, it would be length times width, x times x, or x squared units, whatever your units happen to be. And then for volume of a cube, if it's length times width times height, and each of those measurements are x, length times width times height, because they're all the same measure, would be x cubed. So in that first formula, we added bases, or x's rather. In numbers 2 and 3, when we multiplied, we added the exponents, right? X times x is x squared. So, and we're going to put all this together here in just a bit. So for now, I want you to do this next section with Google. It says, fill in the following blanks with formulas or explanations. Okay, so for area of a square, which we kind of already talked about, I want you to Google area of a circle so you can remember that formula. And then I want you to Google how to write a ratio of two things. We're going to bring all this together in that picture on the bottom, which we'll do together, the picture. Right now, I'm just asking you to do where I had those red arrows. Just take a minute and do those things. And if you're watching the video, pause and do those parts where I drew the red arrows. The picture on the bottom we'll do together. Here's what you probably found. The area of a square, like when you Google that information, it usually comes up with this. It'll say S squared, where S stands for whatever your side is. And then when you Google area of a circle, generally it comes up with this formula, pi r squared, where r is the radius length. And remember, that's half the distance of a circle from the center to the actual circle itself, that measurement. And for a on s squared, the s stands for side. And then when you're writing a ratio of two things, a ratio is when we in mathematics, we're comparing two things together, but we generally will write it as a fraction a lot of times. So if I was comparing, let's say, two values a to b, I'm comparing them. We could write it like this, a to b. Sometimes we write it with a colon. But for the lesson or the exercise we're about to do, we're going to write it as a fraction, a over b. Because then when you write it as a fraction like that, it's easier to do math on it. So that's what we're going to do here on this next problem. So take a minute and read this and look at that picture and just think about it, what it's asking. Just spend some time thinking about how you might set up that problem, and then after about a minute, we'll talk about it together. Okay, so I'm going to sort of get you started and then let you try and finish this on your own. It says, using the graphic below and the information you found, write the ratio of the area of the circle to the area of the square. So up here, when I wrote A to B, so if you see, whenever you see a sentence in this form, you can write it as a ratio as this, A over B. What it's saying in this problem is, instead of A, it's saying, it's saying write the area of the circle, a ratio of that to the area of the square. So think about what we said about the formula for area of a circle and the formula for area of a square, and write those as a ratio. And you can use those two formulas that we just wrote right on top that we talked about. So we probably are good with these individual things that I said here about s squared and pi r squared, and at least that if you want to write a ratio, a to b, the a is going to go on top and the b is going to go on bottom. In this specific case, it looks like this. Instead of a on top, I have area of a circle. So the area of the circle will go in the numerator. And I'm comparing that to the area of the square. And that's going to go in the denominator. Is pi r squared. And the area of any square is s squared, where s stands for the side of the square. So in class, are you all good with that? You see where I'm going? Okay. So the thing, though, in this square, we don't have to use just s. Like, here's the side. But we actually have some more information. We know that this distance here is r. That's the radius of the circle. And that length is the same as this part of the side. This is r. So if half of the side is r, how could I rewrite, instead of s, what could I say the length of that side is using r only? 2r, perfect. That's exactly what I'm trying to get here. So instead of s, we're going to call the s 2r because it's r plus r, okay? And now what I'm going to do with that is go back over here to my ratio, which was pi r squared over s squared. But I don't need to use that s anymore. I'm going to use 2r instead. So instead of s squared, I'm going to have 2r squared, but I need to put that in parentheses because the whole thing is squared. So we have a ratio of the area of the circle compared to the area of the square, but we need to write it in simplified form. So here's where our exponent rules come into play. Look at the denominator, the stuff on the bottom. There's two things inside being multiplied. That's called a product. And they're being raised to a power. So we have a power of a product. And when we learned that rule the other day, we knew to take that power on the outside and distribute it to everything inside. So now that denominator is going to look like 2 to the 2 and r to the 2. And I still have pi r squared up top. So then I can actually do the math on the 2 squared. That's going to give me, perfect, thank you. So I have pi r squared over 4r squared. And I need you to look at that, and the problem told me to write it in simplified form, and there is something here that I can simplify. What do you see that cancels here? The r squareds, right? Whenever you have the same thing on top and bottom, it simplifies to 1. And we don't write the 1 because when you multiply by 1, it doesn't change anything, so we just say cancels out. And so then what we have left here is pi over 4. And then whatever the units are, because this is just a generalized problem. And so this kind of math could come in handy, for example, if you're planning like any kind of landscaping, and for whatever reason you needed to know the ratio, you're planning some kind of square area, you've got something in the middle, like either a round area for plants, or maybe it's like a pond, not a pond, but like a fountain, or something like that. You might want, and you wanted to scale it up or down. This kind of math would be helpful for something like that. Does anybody need the screen up anymore? It says that Gwinnett Pit consists of a circular stage surrounded by circular levels used for seating. Each seating level is 1 meter wide. And it says, suppose the radius is x. Find the area of the third seating level. So that's a lot of math. You probably stopped listening after about the second sentence, but let's put this, we're going to put this all together. We're going to first draw a picture of just the innermost circle. Actually, let me do it. And it says, okay, that's a terrible circle, right? But still, you get the point. The radius of that is x meters. So the radius is the distance from here to here. Okay, so the radius is x. And then if you imagine we have all these other circles here. You know, and so forth and so on. When we want the area of the third seating level, so that does not include the stage. So this is the first seating level right here. And it, or sorry, not it, let me go to the next seating level. So that's the first seating level. This is the second one. And this is the third one. So if I'm trying to find the area of the third seating level, it's a circle. And the area of a circle is pi r squared. What I need is this distance here. That's its radius. And in order to find that, I have to go back to the problem right here where it says each seating level is 1 meter wide. And so if the radius of the interior one is x, we add 1 meter to that for the next area. 1 meter for the next one, and then 1 meter for the last one. And so the entire radius then is going to be the x plus 1 plus 1 plus 1, right? So the radius equals x plus 1, which is x plus 3. And so now that that's our actual radius, we can plug it into that r right there. And have pi times x plus 3 squared. But we need to FOIL that out. So what I would like for you to do for a moment. Actually, yeah, let's do that. So FOIL this out. This really means pi times x plus 3 times x plus 3. So take a minute and FOIL this, and just put done in the chat when you're done, please. Keep foiling. I'm going to show the work up here so that you can, so people who are done can see. But in case you're still working, I won't talk about it, so you can still think. So I have pi times x squared plus 6x plus 9. And then if you distribute that pi through, you'd have pi x squared plus 6x pi plus 9 pi. So who has that? Did you guys get that? So what that got us is actually the area of all of this stuff here. That's what an area of a circle is, but we really just want the area of the third seating, which is this stuff. So what we need to do, so we really just want the area of the red stuff. We need to subtract the area of this yellow stuff. So this is kind of like a geometry review, but practicing with exponents. So in order to find that, we find the area of the yellow stuff now. And we need the radius there. The radius is just this piece, x plus 1 plus 1. I don't know if y'all, has anybody ever seen her? Because you want to get the joke. So I'm moving on. So to find the area of the inner two circles, it goes like this. Same process, but now it's pi times x plus 2 squared. So you do your FOIL on that, just like you did with the last one, and I'll do mine. And then we'll talk about what to do with that information. So this is pi times x plus 2 times x plus 2. So that's the area of the yellow. Pi x squared plus 4x pi plus 4 pi. And then the green stuff was the area of the whole thing. So in order now to find out just the red third level, we subtract those from each other. So that's going to look like this. The green stuff, which was pi x squared plus 6x pi plus 9. And we're going to subtract all of the yellow stuff, pi x squared plus 4x pi. So you distribute that negative. And I'm just going to bring that down underneath here. And I'm going to line up my like terms. So I'm going to have a negative pi x squared, which I'm going to line up under this one. A negative 4x pi, which I'm going to line up under here, because they go together. Oh, that's not a 4 pi. But this was a 9 pi right here, right? I think I wrote this one. Yeah, this was 9 pi right here. And then minus 4 pi. So those first two terms cancel out. And then 6x pi minus 4x pi. Remember when we talked about how you just do the math on the coefficients only? So it's 6 minus 4, which is 2, and then you just bring that x pi down. And then 9 pi minus 4 pi is 5 meters squared.